First of all, every single time, if you remember from yesterday, there are certain procedures that you want to follow so that your grader knows that you know what's going on. Tyler. So in the first part here, when they talk about your SAT scores that are approximately normal with a mean of 500 and a standard deviation of 100, the first thing that you're going to do is you're going to draw a normal curve. And on that normal curve, you're going to place your mean, first of all. And the instructions are to identify the scores that are 1, 2, and 300 standard deviations away from the mean. So our first standard deviation would be 100 away. Then our second one is 200 away. Our third one is 300 away. And then you just go in the other direction, 100, 200, and 300 units away from the mean. Okay, second it says, what proportion of the students scored above 680? So the question that they're posing is, what's the proportion or probability, remember it means the same thing as area, percentages, of your scores, they usually use an X to denote score or some kind of value, are more than 680. Now in order to do that, you need to find out your z-score. So you find your z-score by taking your score. So your z will be equal to 680 minus the mean, which is 500, divided by your standard deviation, which is 100. And so simple math, 180 divided by 100, 1.8. And this is your z-score. So for us to find that, what we're going to do in our calculator is we're just going to go normal CDF, 1.8, and yesterday I used 99. You can use 999 if you want to, because you're going to the right. And you end up with 0.0359. And if I were to draw, which I probably should do for the grader, what's going on, one way I can indicate that I know what's going on is I can put the mean and then 1.8 for my z-score, and I will indicate to my reader that I'm looking for all the scores that are to the right of my 1.8 z-score. And I know that 0.0359 proportion is the area under the curve, or the probability, the area, that kind of thing, of students that would score above 680. So your answer for the probability or the proportion that this is going to happen is exactly the answer we found in the end. So I would write down equals 0.0359. Okay, so in this second part, unlike the first one, this is going to be a below kind of problem. So if I drew my picture of what was happening, this time instead of writing down the z-score, I'm just going to write down, and you can do either one, I'm going to write down the actual scores. And I'm looking for all of my scores that are less than 420. So the question is asking us again, what's the probability or the proportion that my scores are going to be below 420? So in order to figure that out, I find my z-score by taking my score, minusing off the mean, dividing by the standard deviation, and I get negative 0.8. And then, in order to figure out my answer, I will go normal CDF. Remember that you're going from the left now, so it's negative 999 or negative 99, and then you're going up to negative 0.8. And my sources say that I get roughly 0.2119, which is the answer to what is the proportion of students scoring below 420. And again, this is written in a decimal format because they did not ask me for a percentage. If it was a percentage, I would have wrote it as 21.19%. And the last one, same problem as the other two, except now they're doing both ends. You can use your table if you want to and subtract, or you can just find the z-scores and go between. Ready, set, go. Okay, so in this last problem with the style of finding the proportion in between a couple of scores, again, we draw our picture. And this time I'm going to go back to using the normal graph. I talk about stating my problem. I'm looking for the proportion of scores that are going to fall between 370 and 650. That's my goal. So I find the z-scores for both of these. The first z-score would be 370 minus 500 over 100, which would be a negative z-score, negative 1.7, no, 2.3, sorry. And then my second z-score,
Negative 1.3, isn't it?
Yeah.
1.3, my bad, sorry. Yep, 1.3. And then my second z-score would be equal to 650 minus 500 all over 100, so that's positive 1.5.
Yeah.
And then to find my answer, of course, I'm going to go normal CDF. And kind of the nice thing about this one is the two numbers are the numbers that you see, so negative 1.3 to 1.5, and what'd you get?
0.8364.
0.8364? Which is the answer to the question. And then I would put, of course, on my graph over here, negative 1.3 and positive 1.5. And then I would shade everything that was in between those to indicate to my reader.
Why do you write down the z-score instead of
The z-scores are so you can use normal CDF. Okay, this last one was in part of the reading from yesterday that I'm not really sure if you read it or not. But they're asking about, what about the scores between the middle SAT scores, or the middle 90th percentile? So if I'm drawing a picture about what this means, my picture looks something like the following. I have a normal curve, and what I want to have happen when I look at my mean in here, this is my x bar, this would be some score, I don't know what it would be, this would be another score, whatever it would be. They're talking about all the values that would fall inside here such that the proportion would be 90%. So inside of here, I want there to be 0.90. That means that my tail over here has 0.05 and my tail over here has 0.05. So if you want to find that, you actually would need the z-scores for these two values. We haven't done this yet in our class, but there's a way on your calculator to find these values. So the way that you would figure that out is, for example, if I wanted this first value right here, I would go inverse normal, which is on your calculator, I believe it's second distribution. And then since you're in the normal distribution, you would just type in 0.05. Or in other words, this is saying, what's the z-score associated with this first value here at 0.05? And you will find out if you do that on your calculator that you get negative 1.645. Give that a shot. For your second score, since you're all the way past the 90, obviously, you know that you're going to have more than 90% of the data. And that second score is at 95th percentile, so you're going to say inverse norm, 0.95, which should give you a z-score of 1.645, which kind of makes sense because it's symmetric. Now the thing is, if you're doing this, and you want to find out the score, like for example that first x score that we were talking about on the left at 0.05, we know the mean is 500 for the SAT. So to find that first score, what you would do is you would take that 500 for your score on the SAT, and then you would subtract off 1.645, because you're 1.645 standard deviations below the mean, times whatever your standard deviation is. Because this 1.645 is talking about how many of those standard deviations are you below the mean. So I multiply that by 100, and that x1 score is going to be 335.5.
Correct.
Right?
Yeah.
335.5. The next z-score, or sorry, the next score, pardon me, would be the same thing but with a plus in between. I take my mean, because I'm at 500 for the mean score, and this time I'm moving 1.645 standard deviations to the right or above that, and each standard deviation is 100. So I multiply that by 100 to see how big of a score I jump, and when I do that, I get 664.5. Now I ran out of room, but what you want to do in statistics, at least on the exam, is you want to write down scores from 335.5 to 664.5 would put you in the middle 90th percentile. Write it out as a sentence. Example number 2, very similar to the previous example. We're talking about normal distribution of IQ scores. There's a mean of 125 and a standard deviation of 8. So the thing that I want to do is I want to be able to talk about an IQ score in the 80th percentile. So I draw my picture to demonstrate that I understand what's going on. So as I look at what's going on, my score, here's my mean, something to the right of that, because that's the 50th percentile, would put me in the 80th percentile. So I'm talking about the area over here that I want to be above. Remember that your percentile means all these people are below you. And inside of there, we are talking about that's 0.8 or 80%. So in order to do that, what I'm going to do is I'm going to go inverse norm of 0.8. And then that gives me a z-score of 0.84. So this is my z. And then, in order to figure out what my value is, I know that my x will be my mean, whatever that was, which was 125, plus 0.84 times my standard deviation, which was 8, and I get approximately 131.73. And then, of course, you would write a sentence that says a score of 131.73. You probably should say an IQ score, sorry, of 131.73 would place a teacher in the 80th percentile. Because again, they want you to say it. So write the sentence. In part B, a little bit different here. They want the middle 70th percentile. So as you draw your picture this time, and you have your mean, what we're talking about are 2x scores. And the shaded region in here, and notice the first time I wrote it as a decimal, talking about the proportion, maybe it would have been wiser for me to write down 70th percentile or 70% in the middle. And so in order to figure that out, I know that if that's true, that each of these tails has to have 15%, or in other words, 0.15 as a proportion. So I could do inverse norm of 0.15, which would give me negative 1.04. And from our previous problem, we know that since this is symmetric, you should see the other score be positive 1.04, right? So if I go inverse norm, and this time it would be 0.85, I should get 1.04. And then to find these two scores, so my first score, my x1 that is, would be equal to my mean, which was 125.
Yeah.
Thank you. Minus 1.04 times 8. So I get a score of 116.68.